the most advanced war machine ever built by human hands.
Mach 2 capable, radar invisible, armed with weapons that can destroy targets 60 miles away. It can outrun a bullet. It can pull maneuvers that would kill an untrained body in seconds. And yet, there is a ceiling, an invisible wall in the sky, around 50,000 feet. Above that line, the jet cannot climb, cannot function, cannot survive, not because of enemy fire, not because of mechanical failure, because the sky itself stops cooperating. And here's the truth, that ceiling isn't a design flaw. It is physics enforcing a boundary that no amount of engineering has ever fully broken. The most powerful flying machines on Earth are stopped cold by the same invisible force that governs every breath you've ever taken. If that kind of hidden limit makes you think differently, subscribe to Simple Facts. Every week we expose the invisible walls running. The world around you. Rewind. Before jets. Before engines. Before any machine attempted to conquer altitude. Early explorers climbing high mountain ranges discovered a brutal, simple truth. The higher you go, the less air exists.
Not less wind, not less temperature.
Less air, less density, less of everything the body depends on to function. At 18,000 feet, oxygen levels drop to half of what exists at sea level. Climbers become slow, confused, weak. Their muscles stop receiving adequate fuel. Their judgment dissolves. Their bodies begin shutting down, not from cold, not from exhaustion, but from simple oxygen starvation. The atmosphere thins with altitude, the same way a crowd.
Thins as you move further from the center. At the edges, almost nobody.
Almost nothing. The mountain didn't need weapons to stop human advancement upward.
It just needed thin air.
And thin air, it turns out, stops everything. Enter the mechanism. A jet engine is not magic. It is a precisely engineered air processing machine. Here is the survival analogy that locks this in permanently.
Think of a jet engine as a living predator, a shark. A shark doesn't swim through water passively. It forces water through its gills at high speed to extract oxygen.
Without dense water moving through, the shark suffocates.
A jet engine works on identical logic. It pulls massive volumes of outside air into its intake.
It compresses that air violently, increasing its density and temperature. It injects fuel into the compressed air and ignites it. The expanding combustion gases blast
rearward with enormous force, generating thrust.
The entire system depends on one non-negotiable input: dense air. At sea level, the atmosphere provides roughly 14 pounds of pressure per square inch. Thick, rich, workable. At 50,000 feet, that pressure collapses to less than 2 pounds per square inch.
The air is so thin, so sparse,
so molecularly empty, the engine cannot pull in enough volume to sustain combustion. The compressor stages spin, but find almost nothing to compress. Thrust drops catastrophically. The engine begins to suffocate, exactly like the shark pulled from water. And simultaneously, at that altitude, the aerodynamic lift keeping the aircraft in the sky collapses too.
Wings generate lift by creating pressure differences between their upper and lower surfaces. No dense air, no pressure differential. No pressure differential, no lift.
The jet stops flying and starts falling. Two separate systems, propulsion and lift. Both fail simultaneously at the same altitude ceiling.
For the same root cause.
Thin air defeats engineering every single time. Now see where humans pushed.
Hardest against this ceiling.
And what it cost. The SR-71 Blackbird, built in absolute secrecy during the Cold War. Designed specifically to operate above
85,000 feet.
Beyond the reach of every missile and interceptor of its era. Engineers solved the thin air problem. Not by fighting it, but by redesigning everything around it. Engines that could compress ultra-thin air at Mach 3 speeds. Titanium airframes because aluminum melts from friction heat at those velocities. Fuel used simultaneously as a coolant.
Because nothing else could survive the thermal load.
The aircraft ran so hot at cruise speed that it expanded several inches in length during flight and leaked fuel on the ground.
Because the panels only sealed properly once heat expanded the frame.
Every solution created a new problem.
Every boundary pushed revealed a harder boundary behind it.
The program cost billions, demanded entirely new metallurgy, new fuel chemistry,
new pilot physiology protocols.
And it still operated within atmospheric constraints, just slightly higher ones. No machine has ever truly escaped the ceiling. They've only renegotiated where it sits. 50,000 feet is not a failure of ambition. It is the atmosphere drawing a precise, physical, non-negotiable line. Below it, you fly. Above it, the rules change. The medium that makes flight possible becomes too thin to sustain it. Every system has a boundary condition, the point where the environment stops supporting the mechanism.
The greatest engineers in history didn't ignore those boundaries.
They studied them obsessively. They found every millimeter of margin available, and they used it completely. But they never pretended the boundary wasn't real. The ones who survive, in the sky, in business, in life, are never the ones who deny the ceiling exists. They are the ones who understand exactly what it is, why it is there, and how close they can operate to it without crossing into collapse.
Subscribe to Instinct Timelines, because every limit has a logic. And knowing that logic is the only real advantage that ever existed.